Hi everyone. In today's lesson, we're going to talk about finding inverses of a function algebraically. In geometry, you learn to find the inverse of a figure, right? If we took this triangle and reflected it over this line, we would find another triangle. So to find the inverse of a figure, you actually reflected all of the points over the line y equals x. You might even remember that in order to find the inverse, you actually had to switch the x and y coordinates. Notice how point A went to A prime, negative 4, 2 went to 2, negative 4. So when we find inverses in geometry, we actually switched the xy values. So we switched x and y, okay? In Algebra 2 and also pre-calculus, to find an inverse of a function, we will reflect an entire function over the line y equals x. So we're not actually moving figures, we're moving functions. And to find the inverse of a function, what will we do? We'll switch the x and y values, just like we did in geometry. Let's test one out. Let's look at this point right here. This is the point 0, 1, and I reflect it over this line here, which is the line y equals x. We get this point, which is 1, 0. Now, this function you may not have recognized, but this is an exponential function. This is something that you should have learned in algebra. This is an example. This might be like y equals uh, 3 to the x. That's a good example of an exponential function. And this function is something that you should have learned in Algebra 2, but if you didn't, that's okay. You'll learn it eventually. This is actually a logarithmic function, so this would be y equals log base 3 of x. So this is just an example. Don't stress so much about the exponential and the log. We will worry about that at another time, but all I need you to know right now is that to find an inverse, we will reflect over the line y equals x, and to do so, we'll switch the x and y values. Okay, so we know basic function notation. We've seen this before, like f of x, g of x, k of x, right? No matter what type of letter we choose, function notation is f of x, right? So there's something called inverse notation. If I'm asking you to find the inverse of a function, we actually write it as f negative 1 of x, or g negative 1 of x, or even k negative 1 of x. So when you see this negative 1 next to the function, know that we are talking about the inverse. Okay, so we kind of talked about a relation. Here is a function f of x. This is a relation, it's a set of all points. And I'm asking you to find the inverse relation. So really, we know that inverse, to find the inverse, we have to switch the x and y values. And we know that inverse notation is f negative 1 of x. So let's write it out. F negative 1 of x. So what do we say? Switch the x's and y's. So if this point is 3, 4, then that point becomes 4, 3. If this point is 1, negative 2, then that next point becomes negative 2, 1. 5, negative 1 becomes negative 1, 5. And the last point becomes 2, 0. And we can just go ahead and put those little set brackets there. That just means the set of all points. And that's my inverse. So the second question is saying, is the inverse relation also a function? So this is my inverse function. And we want to know, is it a function? So and remember, a function, every x has to go to one y value. So I always like to draw my mappings because that's easier for me to see. So we have 4, negative 2, negative 1, and positive 2. And we go to the points 3, 1, 5, and 0. So 4 goes to 3, negative 2 goes to 1, 1 goes to 5, and 2 goes to 0. So definitely yes. So yes, and the reason is every x value gets mapped to 1 y value. So definitely. Awesome. Okay, I'd actually like you guys to try number 2 on your own. But before you do that, I just want to make a couple of notes. This is a table of values. A table of values is the same exact thing as a relation. You can just write them as points. So if I wanted to write this as f of x, as a relation, like example number 1, we would put -3 and 5 together as one point. So this would be -3, comma 5. -1 comma 6, 0 comma 7, 3 comma 8, and 4 comma 5. So you can feel free to write your f prime, excuse me, f negative 1 of x, your inverse, as a relation, just like. All right, so you can get started. Hit pause and then hit resume when you're ready for the answer. Okay, so f negative 1 means inverse. So inverse, we said, means to switch the x and the y values. So I'm going to go over here and switch all of these points. So -3, 5 is actually going to become 5, -3. Then 6, -1. 7, 0. 8, 3. And 5, 4. So that is my inverse. All right, so now part B says, is the inverse relation also a function? So I think the best way to do that is if I could just draw a mapping like we did before. So we have our x map and our y map. So I'm going to go ahead and put all of the x values in this box and then the y's in the other. So what do we have? 5, 6, 7, 8, and then we have another 5, so I don't have to write it twice. So we have y's are -3, -1, 0, +3, and 4. So let's draw our arrows. So we're going to go from, starting with this one, 5 to -3. So 5 to -3, 6 to -1, 7 to 0, 8 to 3, and then 5 to 4. So that should be drawing a red flag. This x value is going to 2 separate y values. So therefore, this one is not a function. So the answer is no. And the reason why is because not every x value is mapped to one y value. And if you want to get even more specific, you could say the x value of 5 is mapped to a y value of -3 and a y value of 4. Awesome. Let's move on to the next part. Finding inverses algebraically. So instead of a relation, I could give you a function. So in this particular example, I'm giving you y equals 2x plus 3. So I'm giving you a line and I'm asking you to find its inverse. So if we follow the steps, the first step would be switch the x and the y values. Okay, just like in inverse fashion, that's what we do. So instead of this y, we're going to make it an x. And instead of this x, we're going to make it a y. And then we can replace everything else. We have equals, we have a 2, and we have a 3. Okay, how else would we solve? Step 2, solve for y. This will be your inverse function. Okay, so we could do that. Get y by itself, we can subtract 3. So we have x minus 3 equals 2y. We could divide all pieces by 2. So we get y equals, there's technically a 1 there. So I could write this as 1/2 x minus 3/2. And this is my inverse function. But we have to write the notation properly. Make sure we write our final answer as f negative 1. So f negative 1 of x is equal to 1/2 x minus 3/2. And that is my final answer for the inverse. Okay, let's try a different example. Example number 2. Here's our f of x. They want us to find our f negative 1 of x. Notice how sometimes they'll say inverse and then sometimes they'll say f negative 1. So you need to know that inverse means f negative 1 and that this inverse will turn into that notation at the end. So we've written this example as f of x, and we know that f of x is the same thing as saying y equals. So here, this guy is your y, which we're going to switch to make x. We're going to bring down our equal sign, and then we're going to make all these x's y's. So we have a y on the top, a plus 1, and we have now a new y on the bottom. So what we're going to do now is solve for y. So solving this equation is very different than solving this one. You have one fraction on one side, and then you have nothing on the other. What you could do is technically put this over 1 and cross multiply. So when we do x times y, we're going to get xy, bring down the equal sign, and then when we multiply y plus 1 by 1, we just get y plus 1. So the idea of step 2 here, where it says solving for y, is actually going to be a little bit more challenging because there's y's on both sides. So what you're going to want to do is get all of the y's to one side. So we're going to subtract this y. So we have xy equals, xy minus y equals, these cancel, 1. So I'm going to write a little step here. Get y's to one side. And then we want to use a nice little factoring technique called GCF, because there's really no way that we could isolate this y without doing that. So if we take out a GCF of y and we divide each of these pieces by y, these will cancel and we'll be left with x. And then y divided by y, anything divided by itself, was 1. And now look at this. The y is by itself. All we have to do is get rid of these parentheses, which the opposite of multiplication is division. So we could divide by x minus 1. So we'll get our final answer to be y equals 1 over x minus 1. And then if we want to be specific about how we're writing our answer, we have to make sure we put it back into f negative 1 of x, which is our inverse. So 1 over x minus 1. Awesome. Now, if this one was a little confusing for you, don't worry. We're going to go over many more examples like this in class. So just make sure you're writing down these important notes on the side so that way you're ready for tomorrow. All right, so the last problem we want to do is number 3. I actually would like you guys to do part A by yourselves, and then I'll do parts B and C with you. So try it on your own and then hit resume when you're ready for the answer. Okay, so what is the inverse? Well, first, I want to write this as a nice, pretty problem. It says f of x. Let's make it y. Y minus 12 equals 3x. Then I want to switch my x and my y values. So this gets the x, this gets the y, and then I bring down everything else. And then I solve for y. So I divide everything by 3. So I get y equals, technically there's a 1 there, so 1/3 x and then minus 4 because 12 divided by 3 is 4. So if I write it with proper notation, I have f negative 1 of x, which is equal to 1/3 x minus 4. Okay, awesome. So part B says find f of 5. So f of 5 is my original function. F negative 1 is my inverse. So this guy up here is my original. So what that means is everywhere I see an x, I'm going to put a 5. So I'm just going to rewrite the original. So f of 5 minus 12 equals 3 times 5. Everywhere I saw an x, I put a 5. And then let's solve. So we have f of 5 minus 12 equals 15. And then just add 12. So f of 5 is equal to 27. And f prime, or excuse me, f of -1 of 5, this is your inverse function. So what I'm asking you to do is find the inverse when x is equal to 5. So if this is my inverse, I'm actually just going to rewrite it. So I have f -1 of x equals 1/3 x minus 4. And if I want to find f -1, the inverse of 5, everywhere I see an x, I'm going to put a 5. So 1/3 times 5 minus 4. And then if you want to do this in your head, you absolutely can. Or you could just go ahead and type it into the calculator and then hit resume when you're ready for the answer. So you should have gotten -7/3 as your final answer. All right, that's it for today. If you have any questions, please jot them down and we will see you in class tomorrow.